Hi guys, today we are going to take a minute and go back and think about dot plots and their distributions. Now we've already learned a lot of information we can get from a dot plot. We can find the range easily. It organizes our data so that we can find the mode. The median's pretty easy to find. We can even find the mean. It helps us just to organize that data. But there's another way we use dot plots, and that's to look at the distribution of the data. And we're going to talk about what that means today. Our ICANN statement that we're working on is I can describe the distribution of data on a dot plot or histogram. Now, we're not going to talk about histograms in this video, but the information you learn here is applied in the same way to histograms, and we'll talk about that when we come back together as a big group. So, recall, dot plots. They're a data representation that uses a number line and X's, dots, or any kind of symbol really to show frequency. So let's take a minute and look at problem number 1 and create a dot plot, keeping in mind that our data that we're going to be plotting on our number line isn't going to be all whole numbers this time, and that's okay as long as we keep the same scale. So pause the video and create a dot plot for this data. Okay, let's see how you did. Don't forget, you need to have a title. Now, in this dot plot, they also labeled the price down here. That's important. The more information you give the person reading your data display, the better they're going to understand it. Notice the data, since there is fractional parts in our data, we were able to show that on our number line as long as we used a scale. Each time I add a new part to my number line, it's going up by 5/10. Okay? So dot plots give us a visual representation of the distribution or the shape of the data. And there are 3 types of distribution that we're going to talk about, and you're going to be responsible for describing on a dot plot, okay? And also on a histogram. So the first one is a uniform distribution, and in this, all the data points have approximately equal frequencies. So basically, I can draw a line across the top of it, and all the data is going to come right up to that line. There might be an exception of one that might go above, or maybe 2, or maybe it's missing 1 down here. That's okay, as long as when I look at the data, what's the first thing you think? Hey, it's all pretty much straight across. This is going to go more on like a gut feeling. The second distribution we're going to talk about is a symmetric distribution. And this is, I could draw a vertical line down the center, and both sides will look about the same. Now again, it might not be exact, but if you get that nice bell curve, that's a good indication that you have a symmetric distribution. So if I were to draw that vertical line down the middle of the graph, it would really divide my data into 2 parts of about the same size. They'd almost be a mirror image of each other, or they would have symmetry. So if this graph is pretty close to having symmetry, we would say it has a symmetric distribution. Now the third type of distribution we have is called skewed. So this is where the data isn't straight across and uniform. It's not going to form a symmetric distribution. It's going to almost look like a slide or a hill, that you would go down. Now, in this case, the data has been skewed to the right. Again, you could, if you wanted to, go ahead and draw a vertical line down the center again. And if most of the data is on one side of your vertical line, and it's kind of got that sloping up or down, or sloping up towards where most of the data is, we could say that it is skewed. And on top of saying just a skewed distribution, you do need to tell which direction it skews towards. So since most of the data, when I draw my vertical line, I see that it slopes up, it's mostly on the right. So we would say this this particular graph that the data has been skewed right. Now, if this data was, if we flipped our graph and more of the data was on this side, we would say it's skewed left. So let's look at some dot plots and let's discuss the distribution. Here we have some data. Mrs. Montoya, she asked her juniors and senior students how many minutes each of them spent studying math in one day. And then she just asked them to round it to the nearest 5 minutes. The results were put into this frequency table. And then later they created dot plots for the data. So let's look at these dot plots and let's discuss the distribution. So for the students that were juniors, notice I'm going to draw a vertical line down the center, and it basically looks symmetrical. I know we've got this one little guy sticking out, but for the most part, this data would be symmetrical. So we could say that the distribution for the students dot plot is symmetric. Now, when we look at the seniors and we draw a line down the center, I notice that it kind of looks like the data is sloping up, or just from a quick visual estimation, I can look and say, you know what, it looks like most of the data is on the right side. So for the students, these seniors, we could say the distribution of their data is skewed right. So skewed right and symmetric. All right, now it's your turn. Here are two dot plots for two track teams. So the data table shows the number of miles run by members of two track teams during one day. We've made a dot plot to determine the distribution for each. So pause the video, determine what the distribution is for Team A and Team B, and then press play. Okay, let's look at Team A first. Team A has a symmetric distribution. If I drew a line down the center, this one was pretty easy. It's exactly symmetrical. They're both reflections of each other. Team B, however, is skewed right, because if I went ahead and drew a line down the center of this graph, I would see that more of the data, a large chunk of the data, lies on the right side of this. It has it slopes up the data. It doesn't make that nice bell curve, and there's not a straight line across. Go ahead, your turn. Create a dot plot for this data. Here is Team C's data. Make a dot plot, then determine the distribution. Pause the video, and when you're done, press play. Okay, let's see how you did. First, making the dot plot. Don't forget, you need to have your title. And here I labeled miles just to give the readers a little more information when they look at this. Now, when it comes to doing the distribution, once again, look, I used 1/2 or 0.5 as my scale because in the table, the data went up by ½ miles. Now, the distribution. For this graph, I would say the distribution is uniform. If I were to draw a line straight across, it pretty much all goes right to that line, right across the top. Yeah, I got this guy and this guy a little bit above the line. But for the most part, everyone, when I take a quick visual look at it, it seems to be uniform. All of the number of miles have been run by about the same number of people. Last one. Now we're going to use a frequency table. From this frequency table, you're going to have to go back and remember what we learned about dot plots and frequency tables. Create a dot plot and then describe the distribution. So two things. Make a dot plot, describe the distribution. Pause the video and press play when you're done. Okay, let's see how you did. Here is my dot plot. This is just showing frequency here, so I didn't put anything down. I just titled it number of siblings. And looking at this dot plot, I can now go ahead and describe the distribution. So for this dot plot, I would say the distribution, if I were to draw a vertical line down the middle, I notice it kind of, most of the data's here, it kind of slopes up, it definitely slopes up. So I would say that the data for this dot plot is skewed left. Okay, we are done with this video. You can go back and watch any part as many times as you need to, but don't forget to WSQ in your notes, and have a great day.